Welcome back. This is video number 2 and practical application number 8 of chapter 4 of the Advanced GIS textbook. In this second video, where we are looking at applying principal component analyses to census data to better understand social vulnerability relative to natural and environmental hazards, we are going to add census data into block group features in GIS by doing a table join, and then we will use that census data to run a principal component analysis. But there's a few steps along the way and details in there which are quite important. Okay, so I've already pulled up the project here and done a few of the steps for us. And so just to save a little bit of time, first thing I noticed when adding in these Tiger feature class data from the census is that they are in a geographic coordinate system, which is why the state of Utah looks kind of pudgy. If you don't like that view and you're working in a more regional area, you could change to a projected coordinate system, such as the UTM system. And so I'm going to do that right here and now. And that's done within the map properties. Alternatively, we could have re-projected the data as well. And, but to get it to look like this, we also need to set the coordinate system of the map. Okay, so first thing you can see that I have done is these are all the block groups for Utah. And outside of the urban areas, we can see that the block groups are huge features. The reason for this is that block groups are designed to fit up to about 3,000 something people in them, if I'm remembering correctly, 3,500 people. But they can be less than, that, like on the order of 1,000 to 3,000 is kind of typical. But they become a great unit for analysis within the urban area because then in these higher densities of population, the block groups get fairly small spatially, about like a kilometer, 1 to 2 kilometers in width. And this is interesting and provides kind of spatial a unit of spatial analysis that can be used to investigate a difference in exposure to things like flooding risk, air pollution risk, earthquake hazard risk, etc. And in this tutorial, I'll look at it relative to earthquake fault ruptures. Okay, so these are block groups in Utah County, but we don't want the whole state. And so the first thing I did was I went into the attribute table for the state of Utah block groups, and I found the county number, which is Utah County, which is county number 49049. I selected by county, so you can do like select by attributes. New selection where county is equal to 049. And so there you see it. And then when those are selected, you can just right-click Data Export Features. It'll only export the selected records, which is Utah County, and save that as a new file. And that's what we have here. Okay, so there's that. Now, the next thing that we want to do is we want to take the feature or the data. We want to add feature data to those block groups. So as we can see in the attribute table, for the block groups that just comes from the census Tiger files, it just contains the information about the state, county, tract, block group, all that combined into a GeoID, and then and then a little bit like area of land, area of water, and kind of centroid of location. So not a lot there. It's just like a basic structure, but we can add on data. And so what I did, and this is shown a little bit in video 1, was to pull data from the American Community Survey from 2023, 5-year data compilation, which are estimates of various demographic information, economic information within those block groups. And so I have downloaded things that might be related to social vulnerability. I've taken those tables and I've modified them in such a way that they're not raw numbers. So for each block group, which is here on the left, there's a population estimate, which is variable. And then for each of these things, like age, there'll be raw numbers. But what I did was kind of simplify those and then normalize them by the number of people. So this first column here is percent male of working age within that block group. So 63.8%, or in ratio form, 0.638 of the people, 1,029, are working age males, or rather the males that are there. It's normalized out of males, and then working age female, a dependent young, etc. But that was with males and females, and that was not really necessary. So I probably don't need those first kind of gendered-based things for looking at vulnerability to earthquakes. Instead, I've got a few others over here. So just generally percent working age. So in these block groups, many of them are over 50%, less than 70% of people of working age. And then percent of people that are potentially dependents, i.e. over age, say, 67, older dependents, and then percentage of dependents that are young, so under age 18. And so having everything as percentages, like percentages of people that are white, black, indigenous, Asian, etc., everything as percentages becomes normalized to the same system of relative scale. And this is important for running principal component analyses. When running principal component analyses, things need to be of the same scale, same order of magnitude, or same units. And so here, this is like percentage or ratio, and so that will work. So we've got them all like that. So we had to do that normalization, and I've got a bunch of different things like education, level of attainment, minority percentages, poverty percentages, and then housing. And so all those things are potentially important. And the first thing we want to do is take that table data, which is as a CSV file down here in my standalone table that I've added in. So I took that Excel data from the ACS. I saved it as a CSV after doing those manipulations to turn them into percentages. And then I've brought that CSV in here, and I then would join it to this table. And I've already done it. So first, you can basically just click Add Join. I've already done this. You're adding to this table this CSV, and you need to have the correct thing to join to, the similar field. And the similar field that you will use in this case is this GeoID FQ in the Census Tiger file, and that will be joined to what I call the FIPS GeoID. And so let me just show you that. So here's in the CSV, the FIPS GeoID. It wasn't called that, it was called geography in the downloaded table, but the number after the US here is the FIPS code. It has this 1500000 US number appended in front of it. I'm not sure why that is, but it's there. Fortunately, within the Tiger feature class, there's the same basically same number here for these block groups. So it has the FIPS code, the GeoID, and then that weird lead-in number. If that wasn't the case, then you'd have to make a new field within your feature class that added that 1500 US or whatever that number is in front of the FIPS code to make that tie-in. Otherwise, you'd have to go back into the CSV file and edit it and add in a field that just had the general GeoID or FIPS code so you can make that join properly. So I've done that. So if we had completed that join, so if we gone join and relates, add join, input field, GeoID, keep all input records, say OK, then you get what I have here. And there they are. So they're added on, all these percent things. Okay, so that's great. You'll notice that I have actually two of these yellow feature classes. One says ACS 2023 UC block groups, and the other says block groups data. So whenever you make a join, the first one that I've got highlighted here, the join is temporary. It looks and appears permanent, but you can easily go join and relates, remove join, and it would go away. Also, when you do math within the table on a join, sometimes it gets kind of funky and doesn't work right. So one of the first things I do after the join, if I'm happy with it, is I'll export the features to a new name, and then the join becomes permanent. So I'm going to close all these, turn that off, turn this one on, and open the attribute table, and you'll see that it has all of my join preserved. Now you can, visualize demographic difference in that feature class. We could go to symbology for that feature class and do it by I don't know, graduated colors of if you want to know where percent of working age is showing up. And so, as we move away from dark, as we move towards kind of warmer colors here, I guess, that's greater proportion of percent working age people within that block group. Okay. So we can already do some pretty valuable things, right, with this nice table join. And we could show other things like percent Asian, okay? And you can see that where there are more Asians and less, right? But that's, we're not, in this case, going to be actually using the features. We're going to turn this feature data into raster data so that we can run principal component analysis on it. Of course, potentially you could do this elsewhere in like a statistical toolbox such as R or MATLAB, and then bring it in here. But if you want to do it within GIS, Principal Components tool is within Spatial Analyst Toolbox, and that is for rasters, okay? So you have to input raster data. So how do we get our stuff as rasters? So how do we get that % Asian as a raster? And so the first thing you want to do is go to what's called conversion tools. And in conversion tools, we are going to go from feature to raster. And then you find that feature and you point at the field that you want to make a raster. So you could do modern housing, and then you output a raster. So I would say, something like Utah County, block group, modern mod H, modern housing. Okay. That for me meant it was built before or after year 1990, when earthquake codes got a lot better. Since we're going to be looking at earthquake hazards, that is potentially a valuable thing. The output cell size for the raster is something that's a little bit funky because this feature class is in a geographic coordinate system. The output cell size is being showed as decimal degrees, and it's really small number. We're going to output, to make this easier to understand, going to output things in a projected coordinate system, which then will give us an output cell size that we can kind of understand. So if this is currently 358.7 meters, so we're in NAD 83 UTM zone 12 north, I'm just going to turn that for all these analyses to a nice round number of 100 meters. And then you click run. And so I'll put that on top. And so this is a raster where within each block group, there's the same value. It has become rasterized, right? It's got these raster jumps, which is different than if we, were to look at things in the actual kind of block group boundaries. So keep that in mind. But nevertheless, what it's showing us, right, is the values, all values in the block group equal, of where there's, in this case, more newer housing, modern housing, more recent than 1990. And so we can see like Saratoga Springs area, North Up and Lehigh, certain areas Alpine and Cedar Hills or whatever this is, and then Southern Utah Valley and then Vineyard have all young housing. And then old housing is kind of like concentrated along State Street, Orem, Provo, and then the little old towns. Okay, so that makes sense. And so we have to run for all of the census data that we want to run through the principal component analysis. We have to make a raster for each of the census data. So you might run this multiple times, and turns out I have like 19 or 20 different variables in here that I've pulled. And so I would run this feature to raster tool over and over again, creating these new rasters and naming them appropriately relative to what I was doing. So % above poverty, % below poverty, or in poverty. I've already done that, so you don't have to see all of that. And you might think, well, couldn't I run this as a batch? Maybe. Maybe not, because I think each time you have to point at a field. So I'm not sure exactly how that would work. And I think it's a good idea to run it individually anyways, because this is something you kind of need to choose and look at and build some intuition about what you're looking at. Like I was telling you about, where is there new housing and old housing, can kind of learn something about the geography as you're doing this, or in this case, maybe I'm confirming what I already knew. But that's still valuable. Okay, so I've created all of these rasters, and they're all down here already. So there was that first one, modern housing. Underneath it, I've got old housing, which I called unsafe housing. And so that is kind of the inverse, right? Okay, and then percent not working, percent working, percent not in poverty, percent in poverty. And notice that they're kind of different, how you show this is important. So here it's like percent non-poverty, and it's color coded as red. So if I go to this one, it would have been much better to flip this, right? So forget how to do that off the top of my head, but you can choose another color scheme that helps. I think you can invert it as well. But color is not really necessary. You could just go to a stretch. And in this case, we're looking at, now it's flipped it for me anyways, and I like this. So percent non-poverty, as we get towards 100%, which is low vulnerability, it's kind of this white color, so it doesn't stand out. And towards 0, where there's more poverty, presumably, is black. Now, this has some caveats. So in the tables that I brought in, there's some block groups, which are basically like Utah Lake is a block group somehow. And that's all water. There's nobody living there, and that's why it shows as 0. And some of these areas are like that. And so we might, when looking at this in final analysis, publication, something like that, we might cut out those parts of these large block groups, which really actually don't mean much in the urban area for looking at these hazards. But just keep that in mind. And then also, as you're displaying these, percent clip is not usually the best way to go. It's nice to use standard deviation. I usually like to look at it, at least at first, in one standard deviation. And so then as we zoom in, we can see that there are some areas, right, that are kind of uniform throughout Utah County. Not a lot of people in poverty, but there are some areas where the inverse may be true. Okay, so I've built all of those up. So we have a lot of rasters to choose from, including other things like education. How do we create the principal component analysis and see what that tells us and shows us about overall social vulnerability to hazards? Because we could look at poverty and it might be something different than age and dependency, and it might be something different than educational attainment. And so kind of like the nexus of all of those things could be giving us our where there's the most vulnerability. So to get at that, we would go back to Spatial Analyst Tools under multivariate statistical tools, and then we look for principal components. And now we can choose what we want to go into our principal component analysis. Now we could put all of these in, and I tried that out. It becomes a bit hard to think about, and also these things go in different directions. Like since I have things like old housing and new housing, they have different directionality of so they're going to be anti-correlated to each other. And a lot of these are like that. So like no high school degree and high school degree. High school degree is good. No high school degree is not good. Of course, better would be maybe some college degree in terms of like where we might expect there to be less vulnerability. And so when building a principal component that is representing social vulnerability, we kind of want to choose variables that are moving in the same direction towards that vulnerability. And so I'm going to input things that might make people more vulnerable. So higher number of minorities, higher amount of poverty, higher amount of unsafe old houses, greater number of people not working. Now that is a little bit weird because sometimes people, it's not a raster of unemployment, it's people not working. And some rich people don't work. So that one's going to be a bit weird. Okay, higher number of dependents that are young, dependents that are old. I'm not going to put in higher number of working age people because presumably they have more ability and less vulnerability, but we could, right? And you know, it's there. I guess, and then what else could you do? Oh, so we got education we need to add in. So so we don't want the percent that are graduate degrees or bachelor's degrees. Let's do percent no high school. And that may be all we do there. So we've got 1, 2, 3, 4, 5, 6, 7 variables. Let's look through these. Working age, no. Let's add in a few of these demographic variables that's not just percent minority, percent Black, percent Pacific Islander, percent Indigenous, and percent. Well, actually, I'm not going to do that because just for example, I'm going to keep it percent minority. So we have only 7 variables together there so far. Let's just look one more time through. Unsafe, not working, poverty. Okay, yeah. So we've got 7 variables. And now if I had time and I would go back to the ACS and get a few more things that are probably missing from here, like percent of people receiving public assistance, not the same as poverty. It might give us a more nuanced view of things, especially where we have working age people that maybe don't have as many resources. That would be an important thing to have. Also, instead of percent not working, I really wanted to get percent unemployed. And then maybe another thing would be percent of people that relies upon infrastructure for getting to work. And the census data has all of these things. These would be quite important. And could have gone back to that Susan Cutter paper about social vulnerability and try to look for some of the same variables that she used as well. But this is a good start. So we're going to call this principal PCA, Utah County, block groups, and I'll just call it, let's see, social vulnerability, or SOVI you could have done. And then I want to put out a PCA SOVI data file so that we can look at how those things interrelate. And then we run it. Okay, so this is a pretty interesting psychedelic thing because right now, what this is showing us is, and I'm going to change this to standard deviation 1. Okay, so it's showing principal component 1, 2, and 3 that has come out of that PCA analysis. We'll look at the table here momentarily. But where things are more red, presumably there's more vulnerability. But there may be different aspects of vulnerability. So some more green and blue might also have different aspects of vulnerability. But what this really shows with different colors like this is different kind of demographic areas. So this part of Orem is kind of showing up as yellow, Prova is showing up as red. Up here in Alpine is looking like very blue. And some of these other teal areas, there might be some similarities between these teal areas and blue areas. And this red area could be similar demographically to this red area. And so it's showing us kind of classes of kind of like demographics amongst these variables. Okay, so let's go to catalog pane and open this table. Oh, and by the way, when you open these tables, they need to be stretched so you can see everything. I inputted the bands as minority, followed by poverty, unsafe houses, not working, dependency, young, old, and then no high school. So I didn't complete high school. And so in the tables, right, there's these correlation matrix between the input variables. So like 7 was no high school. It's quite correlated with whatever 1 was, which was percent minority. So minorities commonly have not finished high school, is what that's saying. Whereas it's anti-correlated with the next thing, number 2, which was percent in poverty. So interestingly, right, just because you didn't finish high school doesn't mean that you're living in poverty, right? So you might be working in the trades. It's not quite as related, although that correlation is pretty weak. Sorry, there it is. Some other things correlated with no high school was number 4, which is not working. So that is interesting. And number 5, which was young dependents. Yeah, so percent minority was the first thing that I put in. That's, as we said before, highly correlated with didn't finish high school. Also, a lot of young dependents. Number 2, which was percent in poverty, is strongly correlated with number 6, which was percent of dependent age people that are old. So a lot of older people are living in poverty in Utah County. And number 4, it's correlated with that, which was people not working. So that goes hand in hand. And number 3 also is highly correlated, which is living in unsafe housing. So, there's a strong correlation between people living in poverty, people not working, living in older houses, and potentially of retirement age. And so this is showing how these different variables relate to each other. Some of them are kind of oppositely correlated, even though they are all telling us things about vulnerability. And so that's where the principal components come in. Because if we look down here at principal component layers 1 through 7, it shows us that principal component 1, which is like a trend through all of the different variables, captures 56% of the variability amongst all of the input variables. And so we can just look in black and white at principal component 1 and see a lot of what's going on with social vulnerability, not everything. Principal component 2 is another 16%, number 3 is 15%, and with just 3 variables, there's what we got displayed up here in these red, green, blue, we're seeing like 89% of the story of vulnerability amongst these variables that we've input. If we could add in a fourth color, a fourth dimension, get up to 96.3%. And so that's where the part of the power of the principal components come in. The other thing is what it shows us in terms of how the principal component layer is tied to the input layers. These eigenvalues here, basically principal component 1, the higher the value in here, the more related of the input layers. So principal component 1 is quite strongly related to input layer 3, 4, and 6, which we were just talking about. So old houses, people not working, and old age, as well as number 2, which was percent minority, I believe. No, percent in poverty. Okay. And whereas principal component 2 is slightly different, right? So that was input layer 1, which if we go back up was percent minority. And that is also related to number 5, which is young dependents. Okay, so principal components 1 and 2 are telling us about 2 different groups of people. So what's showing up is kind of green on this map might be more of sorry, I'm in the wrong. More minorities, more young people, right? And number 7, which is haven't finished high school. Okay, so yeah, there are different dimensions of vulnerability between principal component 1 and 2. And principal component 3, it might be kind of capturing some things that aren't really quite showing up with those first 2. But yeah, so we kind of got 2 different demographics of vulnerable people in Utah County is kind of what this is showing us. There's people that are in poverty, they're older, they're generally not working, and they're living in old houses. And then we have another group, which is they're largely minorities. They are having a lot of dependents at home. They don't have as high of a rate of education. And so that's what those those values are showing us, kind of how those principal components are related. And we could take something from that, like, so maybe that's what that's showing us, is that there's a couple of things that are really important in this area. And so and for looking at, so we could look and plot just principal components 1 and 2 and kind of capture those things. So let's maybe do that briefly. So if we go to symbology and change this to stretch, so we're just looking at one band. And so now we're going to go, again, don't use percent clip, go to standard deviation and go to 1 standard deviation. And we want to invert this. So, and again, like these big block groups are kind of annoying to me because we probably don't want them in there. They're not as important to our analysis. There's not many people living there. Some of them have 0 values for something. So I should have clipped those out, but I did not. But so don't tune your eyes to the big areas. But within kind of the populated part of Utah County here, the darker areas are showing us where principal component 1 is of high value. And so those are areas of social vulnerability related to old housing, older people in poverty. And so that's telling us something about social vulnerability there. And then number 2, this will look a little different, but now it's quite different actually. So this is showing us more about younger people with more people at home and maybe higher percentage of minorities and less educational attainment. And yeah. Okay. So so we've got those tools of the principal component analyses, which allow us to display the different aspects of vulnerability as an aggregate. But we can also go back to individual things. So if we said we just want to look at the input variables and what we deem to be important after running the PCA, maybe one thing that's really important is percent of older people that might be dependents. And this map kind of shows us where that vulnerable population may be residing. Okay, got to invert it. There we go. So there's these certain below block groups here and there where maybe there's over 55 apartments or communities which have concentrated these people, or it could be their older houses that people are living in different older neighborhoods of Orem, etc. So we can also, having looked at the PCA, seen those important things, like obviously percent poverty is really important. So if we bring that up to the top, again, this has already been kind of stretched for us. We can see where people that are living in poverty are living in terms of their block groups. And so that's it. So we've run the principal component analysis. We looked at the table and we've selected the percentages, so normalized ratios rather, of those data tables that kind of go in the same direction of vulnerability to create a PCA or a principal component of social vulnerability. We've seen that in that principal component analysis, there's a couple of dimensions of common vulnerabilities. And so kind of have to look at principal component 1 and 2 and maybe even 3 to really get a full picture. But yeah, in the next video, we will bring in some hazard, like earthquake hazard fault lines, and we'll see how that relates to vulnerable populations. I think we're going to see that it's not quite the story that you usually see. Usually vulnerable populations end up having to be really close to sites of air pollution, toxic release facilities. But with the case of fault lines, they are kind of located usually up against the mountain fronts where there's great views, newer housing, higher value real estate. And so it tends to be opposite relationship. But we'll go ahead and look at that anyways and show you how to do that buffering analysis to make those comparisons. Okay, so that's the end of this video. Stay tuned for the next one.